Let's take a look at composite figures. So composite figures are formed when we have two or more shapes combined or a shape subtracted from a shape. So we can either add shapes together or we can subtract shapes from each other. So let's see what we have in this first example. It says find the volume of the composite. So volume, so we're interested in how much will fill the space. So what does the shape look like? This composite is made up of a rectangular prism, and we can see that here. We've got a rectangular prism with a cylinder removed from the inside. So you can see they drilled out a cylinder, okay, or there's an open space there where that cylinder goes through the rectangular prism. So the first thing we have to do is we have to come up with a plan. We want the volume of this new composite figure. How would we get it? Well, we're definitely going to start with the volume of the prism, right? The volume of the rectangular prism. This is my plan. I want to make a plan. And I need to subtract because they removed a cylinder. So I'm going to subtract the volume of the cylinder. And that is my plan. So I want to make a plan first in words and write it out so I know what it is. And then I want to go find it. So the volume of the composite figure will equal the volume of the prism, which if I look on my formula chart, volume of a rectangular prism is length times width times height. I find the shape and then I find its formula. Okay, so that volume is going to be length times width times height. Length times width times height minus, I need to find my formula for volume of a cylinder. So if I go look at my formula sheet again, volume of a cylinder, here's a cylinder, volume is pi r squared h. So minus pi times radius squared times height of the cylinder. Now, this expression was only one expression. There's no addition or subtraction signs inside of it, so I didn't have to put it in parentheses. But I always could put it in parentheses if I wanted. I could put each in parentheses to emphasize what I'm doing there. But it's not required this time because each of those terms is just a single term. This is a single term, and this is a single term. Remember, terms are separated by addition and subtraction signs, so we only have the two terms here. All right, and now we're ready to plug into our formulas, so let's do that. I need the length. Now look what I'm talking about. I'm talking about the prism in this first expression. So for all of this length, width, and height, I'm looking for the length, width, and height of the prism. So I'm going to call this my length, and I'm going to call this my width, and I'm going to call this my height. So that's just going to be length of 15. Remember, you can choose any of the sides to be length, width, and height, but once you decide, you have to be consistent. So I'm going to do 15 times 10 times 5, and that's my volume of my prism. Now I'm moving on to the next part. I'm going to subtract the volume of the cylinder. So now I'm talking about volume of the cylinder when I look at these values. So I'm going to do pi times my radius squared. And what is my radius? Well, when I come to look, I see we have a diameter. I know that's the diameter because it goes all the way across. So if the diameter is 7, how do we find the radius? The radius is just the diameter divided by 2. So that's 7 divided by 2. Or 3.5 if you prefer. That's a little easier to put in the calculator. So I'm going to do 3.5. So 3.5 squared, and now the last variable is height. Now this height refers to the height of the cylinder, the height of the cylinder. Remember, the height is the distance between the two bases, so between the two circular bases. This is the height. And if I follow my shape over, I see it's 5 centimeters. So it's 5 centimeters. Now, I wanted to emphasize that because if you had labeled the length, width, and height of the rectangular prism in a different way, then you might have had different labels for your height. The important thing to remember is whatever you labeled your height as for the prism, it stays that for the height of the prism. The height of the cylinder is always the distance between the two bases, the distance between the two circular bases. All right, let's put that all in our calculator. So that's going to be 15 times 10 times 5. Minus pi, and we're using our pi button, never, never any decimal approximation for it, our pi button, times 3.5 squared times our height, which we said was also 5. Okay, and that's going to round to 557.6. It's going to round to 557.6. So my volume of the composite is approximately, and I use that subscript to indicate which volume I'm talking about. It's approximately 557.6, and I need my units. I see that they're centimeters, but what kind of centimeters do we have for volume? That's going to be centimeters cubed or cubic centimeters. Let's take a look at another one. So it says find the surface area of the composite. This composite is made up from a cone with a hemisphere on top. Okay, so surface area means only the surfaces that we can touch, only on the outside of the figure. So it said it's made up from a cone. How much of the cone can we touch? How much of the cone can we touch? If we go look at our formula sheet and we look at a cone, so I go find it. Here's my cone. Which parts of the cone can we touch? Can we touch the sides, the lateral area? If I look at my picture, yes, we can definitely touch the sides. Can we touch the base of the cone, that circular base? Is it on the surface of the composite? It's not. It's covered with that hemisphere, so we can't touch the base of the cone. So we only want the sides of the cone. My plan is shaping up. I want the lateral area of the cone, the sides of the cone, and then I want to add to that, how much of the hemisphere can we touch? We talked in our last video about it can be an open hemisphere or a closed hemisphere, meaning we include the circular surface, the circular cross section, or we do not. And if I look at this, I can't touch that circular cross section of the hemisphere either because it's on top of the cone. So all I can touch is the outside of the cone. Well, the outside of the sphere. So that is half the surface area of a sphere because it's a hemisphere. Remember, we don't have hemisphere formulas on our formula card, and we're only going to get our formula card. So when we have to do a hemisphere, it's often helpful to go look at the surface area of a sphere and just cut that in half. So a hemisphere would be half that surface area. If it ends up being a closed hemisphere, then you'll just add that circular base to it from the formulas on your formula card that tell you what the area of a circular base is. Ours is not covered, it's an open hemisphere, so I'm just going to cut the surface area of the sphere in half. So that's going to be half the surface area of the sphere. And this will give me the surface area of the composite. Okay, so that's my plan. So let's go find those formulas. Lateral area of a cone. If I look at my formula sheet, lateral area of a cone is pi RL, pi times radius times slant height, plus half the surface area of a sphere. Now I am going to put that in parentheses because we're taking half of that whole formula. The surface area of a sphere is 4 pi r squared. And now I have my formulas ready to go. Okay, so let's go plug into those formulas. So I'm talking about the lateral area of a cone. So I'm looking at the cone. I want pi times the radius of the cone. Well, it turns out where they placed this radius of the cone is also the radius of the circle. So that'll be helpful. Our radius is 3. L stands for, let's look at the picture and remind ourselves, L stands for the slant height of the cone, And if I look at my picture, that's actually what I have. I have this slant height right here. So that's perfect. That's my slant height. So that's 7. And now we're moving on to half the sphere. It's a hemisphere, so it's half of the sphere. The sphere would have been 4 pi times our radius. We said the radius of the hemisphere is the same as the radius of the cone. That's also 3 squared. Okay, and I'm going to put all that in my calculator. So that's going to give me approximately 122.5 inches. Now, what kind of inches are they? I can see that they're inches. This is surface area. Go look back at the top to see what you're solving for. This is surface area, and area is always square units. So it's 122.5 square inches.